This is J.J. Miller, Senior Product Manager for Drilling Fluids. Welcome to our latest Fluids webinar. Today we're discussing BaraShale Max. To most people, all drilling fluids look pretty much the same. But under their surface, there are some serious differences which affect our drilled formations. Oil-based fluids provide great performance downhole, but bring along a host of added surface requirements for management of the waste. In many onshore fields, water-based systems alleviate such requirements and concerns, but these fluids have always faced some tall challenges with unstable shales in the wellbore. Let's take 2 minutes to look in-depth at stability challenges. Water movement is key to what happens once we drill a formation. Typical water-based fluids have filtrate leaking off into the formation, and this can lead to shale hydration. Effects include a decrease in the strength of the rock, pore pressure increases, so we would need higher density fluid to counterbalance it and hold it in place. At this point, things can get really ugly with formation either swelling or caving into the wellbore, and all this rubble has to be cleared out of the hole before we can run casing, and we may not be able to case off at the depth that we had planned to. The phenomenon is well documented as pore pressure transmission, and this happens shortly after exposure to the fluid. The invaded zone pressure rises to the mud column pressure or beyond it, so at that point there is no longer enough force to hold it back. Several SPE papers like the one referenced here give more details on this. Swapping over to oil-based fluids. These have very low filtrate leak-off rates, and the filtrate is oil, so it does not have the same hydration issue. These fluids also have a low water activity due to their brine phase, and will actually dehydrate the shale. This results in increasing strength and less pore pressure, so that we have an easier time drilling without concerns for time-dependent wellbore deterioration. Sometimes we can even push casing intervals deeper or skip them altogether to save on costs and time to reach the reservoir section. But the caveat here is that oil-based fluids bring along a lot of surface requirements: oil cuttings, containment, transport, and disposal. Trucks like these will have to round trip a large number of loads continuously to keep up with drilling activity. All these added actions come at an expense depending on where the location is. And the oil-based fluids also have to be hauled from location to location. Since we might not be able to use oil-based fluids, and our water-based fluids are not always able to pull water from the formation, we turn to sealing solutions as another way to limit water invasion and cut down on instability. Over the past 4 years, we invested in new materials to enhance our portfolio. The first of these was BaraSeal-957, which has the right consistency and size to provide high efficiency sealing in a variety of situations. Shown at the upper right is a picture of this material dispersed in water under a microscope, and you can see how it forms soft globs of polymer between about 10 and 50 microns in size. BaraSeal was first tested and had successful results on oil-based mud applications. We had 2 of these over the past 2 years. Just this year, we qualified it as a viable solution for water-based applications as well. We tested BaraSeal on the permeability plugging apparatus, or PPA, shown at the bottom right. When we added the product to an existing base fluid, it provided much lower filtrate. Here we can see that the initial spurt of filtrate and the final value after 30 minutes are less than half their original values. This means much better control of fluid invasion and much reduced risks of instability. I'll explain more about our latest field trial for BaraSeal in a moment. So first, let's go back to pore pressure transmission for a minute. Our first nanoparticle product was created to help stop this transmission and the resulting destabilization of shales. BaraFLC Nano-1 is an emulsion which contains dispersed nanoparticles. We have worked with various operators to investigate how it could seal off pressure in shales. In independent laboratory testing, we saw some really exciting results. For 2 different shale studies in our water-based fluids, some with these added nanoparticles, we saw that this product was able to stop pressure transmission at about the same level as an oil-based fluid. For the Wolfcamp shale, both of the water-based fluids contained the nanoparticles, and with the high-performance system, we approximated to the oil-based mud level of delay on transmission. Here with the more reactive Alaskan shale core samples, we had a much higher delay of transmission with the oil-based fluid and the fluid containing BaraFLC Nano. Other test fluids, which were exactly the same but did not have the nanoparticles, were not able to perform better than the baseline of 1, and other inhibitive additives were not effective. And as you can see, the size of these particles is under 400 nanometers, which is actually less than 0.4 microns. And in comparison to the previous sealant, this is less than 1/100th of the size of the BaraSeal-957. Other work showed that PPA filtrate could be reduced to very low levels. And on top of that, we saw improved shale retention with cutting samples from ongoing wells. Breakdown of the drilled material was around 90% in the case of the standard fluid used. And our test fluids with BaraFLC Nano-1 cut that down to 15 or 32%. This means the treated fluid could be run much cleaner with less dilution and treatment required for a longer run life. A lot of different particles have been used to try and seal things over the years. All the work in the laboratory indicated that these 2 materials had the best performance we had ever seen. This gave us the confidence to take them to field trials. The first trial run was in the northern US. Our main challenge was to replace oil-based fluid in an area where water-based fluids have had a lot of issues. We needed to drill through weak and fractured shales which were overlying the reservoir, and this was right at the curve section of the well. We had known instability in the past wells where water-based fluids were used, and they had failures to run casing. We also had to contend with the risks of downhole losses, the need to control our fluid properties with increasing solids, and the ongoing challenge of having bit balling and accretion occur. Our solution was to apply BaraSeal-957 sealing polymer to prevent fluid invasion and fractures. The team built a customized fluid based on produced brine, which underwent extensive laboratory testing to optimize its properties. Our results were very well received by the customer. Regular additions of glycol and lubricant sweeps alleviated any bit balling, and the hole conditions allowed for smooth, trouble-free trips to change out the bit assembly. The ultimate test was wellbore stability for the casing run, and this was completed in 12 hours with 0 signs of trouble. The operator was able to collect clean formation samples according to their plan, and have deemed this a success that they would like to repeat later this year. Now, as word spread about this throughout North Dakota, most people were surprised we could get casing down with a water-based fluid system. But then, when they heard more details, they were all shocked that it had just taken half a day to do it. Our second case study took place just 2 months ago in Colombia. The challenges included, first off, working with no salinity in the fluid. So we had to deliver inhibition with only the environmentally accepted components that we had in our toolbox to stabilize dispersive shales and plastic clays. With BaraFLC Nano-1 sealant, we wanted to enable higher ROP and reduce filtrate invasion, especially in the sand sections. Overall, we expected that this enhanced fluid system could deliver improved hole conditions, making trips and the casing run faster and easier. The solution was to customize their polymer-based water-based fluid with BaraFLC Nano-1 nanoparticle sealant. This fluid was otherwise very much the same as been used for multiple offset wells. Now, like before, we worked hard in the laboratory to refine the fluid. This time, the overall process took about 8 months since we were still learning about the material. We also needed to qualify our solution in a third-party laboratory. We collaborated with the customer to set out some very well-defined performance goals, with primary objectives to keep filtration control at a very high level and to increase their trip speeds. Our results included 40% faster rate of penetration early into the section, very low filtrate values, meeting all of the targets, and trip speeds that were above average with minimal overpull. Some of them were even best in class for the wells that were done. Another issue that happened was 2 days of rig time where we were shut down and could not circulate. We returned to bottom and drilled ahead with no issues in the wellbore. We found through cementing the well that the wellbore was more engaged than past wells, and this allowed for reduced cement volumes. Overall, our 2 key lessons were faster rate of penetration with more than 700 feet faster than planned on the first day, and much better trips with overpull cut down from 30 to 80,000 pounds to just 20 to 30. To summarize, we're now formally launching the engineered fluid solutions I talked about with modern polymeric sealing materials as BaraShale Max. We set out to better meet the needs of onshore operators with this water-based fluid solution. First and foremost, we saw a need to improve the stability aspect of these systems so that we could improve efficiency with drilling itself and all the activities after drilling to complete the whole sections. Delivering stable hole conditions saves operators huge amounts of money and time. While drilling, we ensure that the flow properties are high enough to remove cuttings, but also do not cause pressures which exceed what we can tolerate. Our proprietary software allows us to dial in fluid properties and optimal drill and trip speeds. And unlike most high-performance fluids that need a freshwater source for build and dilution, BaraShale Max can be built with a wide variety of available brines in the field. Last but not least, we combine these attributes with fluids engineering expertise to achieve maximum performance with minimum cost to the operation. A big part of that savings is taking away the waste management costs for oily cuttings waste. If you have questions or want to hear more about BaraShale Max, check out Halliburton.com, where we have the full case studies I described. Click the Get in Touch button if you want to contact us, or you can contact your local Baroid technical professional.